Well, good morning, everybody. I'm Jeanette Lindsay. I'm the Deputy Director of the Fenner School of Environment and Society and also of the ANU Climate Change Institute. And I'd like to welcome you to this first ANU Climate Change Colloquium. We're going to say a few words in a minute about the series that we're beginning with this inaugural colloquium on targets and progress, implications of the Climate Change Authority's final report on Australia's mitigation strategy. Before I do that, though, I'd like to acknowledge and celebrate the first Australians on whose traditional lands we meet and pay our respects to the elders of the Ngunnawal people, past and present. I'd also just like to advise you that this session will be recorded, and except for the question and answer session, we won't be recording that, but the presentations will be recorded, and this will be reviewed and approved by all parties involved and then published on the Climate Change Institute website. So without further ado, I'd like to introduce to you Professor Michael Raupach, who is the Director of the ANU Climate Change Institute. Mike has a long history working with CSIRO, mainly in the Canberra laboratory of the Marine and Atmospheric Research part of CSIRO. He has commenced his role as Director of the Climate Change Institute at ANU in February of this year and has been working very hard and very effectively to initiate a number of strategies for both on-campus and external engagement, and the series of colloquia is one of those. Mike has a very well-known international reputation in Earth system science, carbon, climate, human interactions, land-air interactions and fluid mechanics. He's a Fellow of the Australian Academy of Science, the Australian Academy of Technological Sciences and Engineering and the American Geophysical Union, and of course has published very widely. So I won't say much more about Mike's background, but invite him to come up and speak to you briefly about the series of colloquia that we are now launching.
Thank you, Jeanette. This is a very brief introduction. I will be saying a small amount from a scientific perspective a little later in this colloquium, but the intention here is just to introduce you to the series of climate change colloquia that we, the Climate Change Institute, are initiating, of which this is the first, and we're delighted that Anthea can be here to kick us off in such a wonderful way. The series involves, at this stage, 4, spaced at roughly monthly intervals, but not exactly. The first is today's event about targets and progress and the implications of the Climate Change Authority's recent report. The second, in about a month, slightly less, we'll be looking at the questions of the costs of climate change from a very broad basis, not just the economic costs, but the multi-factor costs, the cost to human well-being, also the benefits of early adaptation and early mitigation for climate change. The third colloquium, towards the end of June, we'll be looking at climate change and the intersections between ethics and policy, how ethical considerations should or ought to be influencing our policy, and the other feedback. And the fourth, in September, will be joint with the Frank Fenner Forum, a series of meetings run by the Fenner School, and that will concern questions of perceptions and facts and the relationship between the way that climate change is studied by the scientific community and the way that it's perceived quite differently in various sectors of the community, with results that we well know in terms of the debate about climate change. So these will be the first 4 of these climate change fora, climate change colloquia. The intention is that they be highly interactive events, and to that end, they will all include a good discussion and answer, a question and discussion session, which will take place at the end of today's forum. So without further ado, I'll hand back to Jeanette to get us underway. Thank you, Jeanette.
Thank you, Mike. As you can see, the program for today is that we will first hear from Anthea Harris. Mike will then talk about the implications of the global carbon quota. We'll then hear from Scott Ferraro on deep decarbonisation pathways, and then Frank Jotzo on whether a 15% reduction by 2020 is affordable. and we then are allowing half an hour for discussion. So we're a little behind starting, but we'll try to leave as much time for Q&A as possible. So that is our program for this morning. I'd now like to introduce Anthea Harris, the Chief Executive Officer of the Climate Change Authority, who has very kindly agreed to come and talk to us today on the topic of the Targets and Progress report that the Climate Change Authority put out in February of this year. Anthea, prior to her appointment with the Climate Change Authority, was Chief Advisor within the Department of Climate Change and Energy Efficiency, and she played a leading role in the development of the Australian Government's carbon pricing mechanism and associated measures. She's contributed to green and white papers on the carbon pollution reduction scheme and served on the National Emissions Trading Task Force in the pre-2010 period. She led the task force to design a national emissions trading scheme to be implemented by the states and territories. Prior to that, she worked with an economics consulting firm on a range of greenhouse policy issues and has held positions with the Victorian Department of Premier and Cabinet and at the Productivity Commission. So Anthea is a very experienced person who has led the Climate Change Authority's very influential report, and we much look forward to hearing, Anthea, what you have to say about this report. So please welcome Anthea.
Thanks very much, Jeanette. We'll
guide us to get your presentation. You've got your microphone, so
Yep.
Okay.
Well, good morning, everyone. Thanks very much for having me here today to talk about the Climate Change Authority's first and possibly only report on what Australia's targets for greenhouse gas emissions should be. So firstly, not all of you might know who the Climate Change Authority actually is. We're a relatively new organisation. We only started in July 2012. So we're an independent statutory authority, and our job is to provide advice, independent advice to the government about climate change policy. It's chaired by Bernie Fraser and currently comprises 7 members. They have a broad range of expertise, so we have climate science represented, economics, business and public policy. So the idea is to get a broad range of views coming together to provide that advice to government. We have legislative principles that we need to take into account, and we must be very transparent and consult when we're conducting our reviews. So the Targets and Progress Review, which is the topic of this speech, is about what Australia's emission reduction goals should be. So we need to have a think about this for multiple reasons. First of all, we need to decide, finally, what Australia's target for 2020 should be. So the government still officially has a range in place. So while we hear a lot of discussion about Australia's target being a 5% reduction compared with 2000 level emissions by 2020, we still actually haven't taken off the table the idea that it could be between 5 and 15 or even 25% reduction compared with 2000 levels. So that officially, from a government perspective, that's still potentially on the cards, and Australia certainly still has plenty of opportunity to increase its target beyond its minimum 5% pledge. It certainly has opportunities to do that this year. And also going into negotiations next year, the government said it would have another look at its 2020 target next year, but also next year it has to be thinking and putting down numbers on the table for targets for beyond 2020. We're not sure how long for yet, but potentially for out to 2030 at that time. The review also covers a number of other matters that are relevant for government policy making, so it has a look back in time to have a look at what progress we have been making in our economy towards reducing our own emissions. It looks at significant opportunities for where we can continue to reduce our own greenhouse gas emissions, and we highlight a few things there in the electricity sector and in motor vehicles, for example. And we also talk a lot about, if we're going to take on stronger targets, which the authority recommends that we should, how we might go about that, and in particular through the use of international emissions reductions, and more about that soon. So in terms of our principles, the things that we had a look at, we of course started with the science. So we're having a look at climate change science. What does that tell us about the risks that climate change poses for Australia, and what does it mean about trying, from a global perspective, about what does it take to try and reduce some of those risks. We have to, of course, have a look at what other countries are doing. Probably most people's kind of initial reaction when you say, well, Australia needs to do more, their initial reaction is, well, what's everybody else doing? You know, we want to be part of an international effort here. We don't want to be sort of going out alone. We need to think about the concept of equity. It's inescapable in this field. You need to have a think about equity between countries and between generations as well. And of course, we want to think about the economic implications of anything that we recommend to make sure that whatever we do recommend is affordable and manageable. We did consult extensively, and now for those, I think there's some in the room who provided submissions. Thank you very much. We start from the perspective that that strong global action on climate change is very much in Australia's interests. This isn't a sort of negotiation, international negotiation that Australia wants to go into, where it doesn't care that much about the outcome, and its main objective should be to get away with doing as little as possible and to try and sort of get a win over others. It really matters for Australia that we get a good outcome from international negotiations. We know that climate change poses serious risks for our society and our economy and our natural environment. So, therefore, if we think about trying to get a good outcome, which is very important for us, we have to be prepared to play our part. It's very difficult to point the fingers at others and say, you need to do more if we can't be seen to be playing our part, particularly for countries that are significantly poorer than ourselves. So what did we recommend? We recommended actually a set of goals. So we recommended a target for 2020, and we said we certainly should go beyond that minimum commitment of the 5% reduction compared with 2000 levels by 2020. And we said we should do at least 15%. And actually, we've got some leftover credits from our first Kyoto commitment period. And we said, which we can still use, you can put them in the bank and use them for later. We said that should be added to it. And we've got basically 4 percentage points worth of that as well. So all up, at least 15, we say you should do a 19% target for 2020. We also have a look out for 2030. Now, we haven't pinpointed a particular number for 2030 at this stage, but we think that Australia should do between 40 and 60% reductions by 2030. And all of this is all in the context of thinking about what a long-term carbon budget should be for Australia. So going all the way out to 2050, we think that Australia should allocate itself and have all of its policies guided by thinking about a long-term carbon budget, and we think that should be in the order of 10.1 gigatonnes, and I'll talk a bit about how we got to that later. So just to put that on a picture, so that solid line is where our emissions have actually been tracking, and that big triangle is all of that long-term carbon budget that we have recommended. That hashed area, the striped area, is the what we have recommended out to 2020, and that range there is that range out to 2030. And you can see that the middle of the range is just sort of using up that carbon budget in an orderly kind of linear fashion. The bottom of that, if you're tracking towards the bottom of that target range, so in that yellow area, you've decided to do that either because you think actually we need an even stricter long-term carbon budget, or you might have decided, you know what, I think we need to go harder now because we need to leave ourselves a bit more carbon budget available for later. If you've tracked towards the top of that that target range, so if you're up at the 40% mark, so the top outside the yellow long-term carbon budget, that means either you've decided to abandon that carbon budget, you've decided, you know what, we're not going to stick to that, we're going to go for something weaker, or for whatever reason you've decided to go a bit softer with the same carbon budget, which implies that you would have to go a lot harder later. So in terms of the target for 2020 that we've recommended, we think it's consistent with science, so in terms of trying to mitigate those risks of climate change. It's fair to future generations. Leaving us at our current minimum commitment of 5% really leaves too much work to do till later. It puts too much of a burden on future Australians. We think it's in line with what other countries are doing, particularly those other countries with which we normally, with whom we normally compare ourselves. So for the United States, for example, they've got a target of 17% below their 2005 level emissions by 2020. The target that we've recommended is in line with what they're doing. And we know that this can be achieved without, still allowing incomes and our economy to continue to grow. So here's just a picture kind of stating the obvious, which is that the more you do now, the less you have to do later. And conversely, if you do a bit more now, then you don't have to go as steeply later. So this is some charts with some different 2020 targets on there. And again, just going from a 2020 point, just using up that whole carbon budget that we've recommended in a straight line fashion. And you can see that obviously the less you do in 2020, so the higher that 2020 number, the steeper and scarier those lines look thereafter. In terms of global action, we can see a long-term trend towards greater action and broader action across different countries. And so here's a picture of what was going on in 1990. No countries had commitments on the table. In 1997, we had 37 countries, commitments on the table. And now we have 99 countries. So these commitments take all sorts of different forms, but we can see more and more countries stepping up to the plate and deciding that they will commit to something about reducing greenhouse gas emissions. Are countries doing enough? No, all countries need to do more, but we do see a trend towards increasing action, not less. In particular, it's very important that China and the US are taking this issue seriously, because just from the straight sort of arithmetic point of view, it's really hard, probably impossible, to try for the world to tackle this problem without those two major emitters doing their bit. But so we can see encouraging things in both of those countries. So, for example, very large investments in renewable energy in both of those countries. Strong vehicle emission standards in both of those countries, subnational emissions trading schemes in both of those countries popping up. Plus we can see a whole raft of other regulatory arrangements in place. So we also have targets in place, both of those countries, and it looks at this stage very encouraging that like they will meet those targets. They are putting policies in place on the ground that mean we have a realistic prospect of those targets actually being met. Now, this might be a bit hard to change, but we'll certainly make these slides available later. It's probably an advertisement to have a look in the report. But we have looked at different Australian 2020 targets and had a look at how you can compare those targets with a range with other countries across a range of different measures, because you think, oh, how does it compare? And you can think of all sorts of different ways that you might think about comparing targets. So we've tried to be awfully explicit about that and put it on a range of different kind of indices. So we've had a look at absolute emissions reductions, we've had a look at emissions intensity, we've had a look at reductions from baseline, from business as usual, with some very big caveats around business as usual. My estimate of business as usual will be different from your business estimate of business as usual, and it will almost certainly be different from the country proposing the target's version of business as usual. And we know, anyone working in this field, it's a very hard concept, because the moment you start doing things, you lock in different pieces of infrastructure, and so your business as usual trend changes all the time. It's a very difficult concept. Nonetheless, we've had a go. And we've also had a look at per person emissions. The big story from this is that, again, that big conclusion that the 5% target looks weak compared with what other countries are doing. And the 15%, something at least 15%, looks much more in line. In terms of the economic implications, we find that the costs of taking on stronger targets are manageable. So here's a picture of gross national income per person out to 2020. The top red line is a picture of if we just stuck with the 5% target. The bottom greeny line is if we took on our recommended 19% target. Now, you can see that it's a bit hard to see the difference. And the reason is that the estimated difference between those two in terms of gross national income per person is very small. So in terms of a growth rate, average growth rate goes from 0.8% to do the -5 to 0.78%, so 0.02% lower rate of growth in gross national income per person, and a very small delay in terms of when you would make that up. So a number of months, a small number of months, and before that would actually be made up. So you'd be back to that same level of national income that you would otherwise have been. So looking out to 2030, and again, just to stress, Australia has to come up with a number beyond 2020 next year, going into negotiations into Paris. We've recommended, as I said, that range of between 40 and 60%, and we think that when you're finalising what that number should be, rather than have a rather long and complicated set of conditions about what you might do under different circumstances, we suggest that actually it makes sense to look at 3 big things, and they're the 3 things that you're always going to look at anyway, so we thought we may as well try and be explicit about that. And those 3 big things are developments in climate science, the level of international action, and economic factors. So in practice, we'll always look at those things anyway. We also recommend periodic reviews of some of these longer term goals. Keep under review longer term goals, target ranges for the future, and certainly that long term carbon budget. So in relation to this long term emissions budget, so Australia has never sort of had one on the table until this report. And the idea is pretty simple. So we think, okay, we want to try and avoid the worst impacts of climate change. Ask the scientists, okay, what does that mean? And they'll say, well, it depends. If you want to stick to this global goal of keeping temperatures below 2 degrees, you have to think about that in probabilistic terms. You can't go, there's not a certain number of megatons that will give different temperature outcomes, at least not in a way that we understand now. So we say, okay, well, what sort of probability do you want of staying below 2 degrees? So all the work that we have done centres on, from a global perspective, trying to achieve a likely chance of achieving staying under 2 degrees of global warming. So that's a 67% chance of trying to stick to that goal. That matters because all the numbers hinge off that initial probability. Then we've had a look at how we should think about, well, if that's from a global perspective, we get a number for that. What should our share of that be? Now that's inherently a difficult thing to be thinking about. What slice of the pie should Australia take compared with other countries? Where we've ended up, it's actually the same approach as Professor Garno had recommended in his reports, and that's called a modified contraction and convergence approach. And what that means is, ultimately, at some time in the future, in our case it's 2050, we think that everybody in the world should have equal rights per capita to emit greenhouse gases. So in 2050, Australians should have no greater right than someone in Bangladesh to put greenhouse gas emissions into the atmosphere. That doesn't mean that actual emissions need to be the same, because different countries might do different things, and then there's a role for trade there, but equal rights per capita. But we do know 2 things. Well, we can't move, it's very unlikely that anyone would move to that initially. We're starting from very, very disparate starting point. So countries like us have enormously high emissions per capita, and we're just not going to go to some kind of global average tomorrow. It's just not realistic for that to occur. And other countries are currently at very low levels, and actually they need a bit of room to grow before they eventually get to this global average level. So this methodology tries to take into account both of that. So we go on a glide path down, but it's a methodology that allows some other countries a bit of room for their emissions to increase a bit before they go down. But all in all, the global budget is met. We know that this target, that's 2020 target that we've recommended is achievable. We've already made some progress, so probably a little known fact is since 1990 the size of our economy has doubled, but our emissions have stayed largely the same. So the emissions intensity of our economy is declining. Now there's lots of reasons for that, and we've actually commissioned some work that's on our website if you're interested, trying to decompose what's been going on. Some of it's been much more luck than good management, so just a general trend towards an increasing share of services in our economy, that sort of thing. But policy has also played a role, in particular in relation to energy efficiency and things like reductions in land clearing emissions. We still see quite a few opportunities to reduce our own greenhouse gas emissions, so energy efficiency across the board is one of those, transitioning to more renewables in particular, lower emissions forms of electricity generation, adopting just more efficient ways of doing things in our businesses and our commercial activities, and continuing to keep a lid on land clearing emissions in particular, and further scope for sequestration through forestry, etc. We do need effective policies now if we want to be reducing our own greenhouse gas emissions, not just to 2020 but beyond. It takes time to develop policies, to put them in place, and then for them to start to have an effect. So if you want to be significantly moving the dial on our own domestic policies, we do need to be getting our skates on sooner rather than later. We estimate that without any other policies, so with our renewable energy target in place and all of our energy efficiency policies currently in place, but with nothing else, so no allowance for the direct action policy, we estimate that our emissions would be 17% above 2000 levels by 2020. So clearly we've got a bit of work to do to bend down that upward growth that we are projecting. We estimate that out to 2020, it would actually take quite a high kind of price incentive to reduce those emissions a lot domestically. But we do know that we can't leave it forever. Domestic activity is important. We don't want Australia to be some sort of high emissions backwater in a future carbon constrained world. Looking particularly out to 2020 though, we think that just because it's hard to reduce our own greenhouse gas emissions over a short period of time, it's already 2014, we've kind of left our run a bit late if we want to be having really big reductions in our own emissions by 2020, we don't think that should limit the contribution that Australia should make to 2020, because we have available to us for this very purpose an international market in emissions reduction. So you can purchase credits that you're allowed to count towards your own country's greenhouse gas reductions. It's a good time to be buying these in the cold hard world of cash in terms of buying things. There are large numbers of these credits currently available at historically low prices. We do recommend that the government could establish a fund to purchase some of these credits. So to make a really big difference to what Australia's target should be, it can buy genuine emission reduction credits and it can do so at a relatively modest budgetary cost. So depending on the price of these units, they're currently trading for well under $1. So estimating between 50 cents and $2 a tonne to buy these things. We estimate that going from a 5% to a 19% target would cost the budget between $210 and $850 million. Here's just a picture of that gap between where we think we need to be, and that's just the 5% target. So there's a significant task ahead just to get to the 5% target. But it's not a tripling of effort, or more than a tripling of effort, to go from 5% to the 19%. You can see that our estimate was a 593 gap between kind of a business as usual and the 5%, and it's actually less than that gap to go from 5 to 19. So when people hear going from 5 to 15, it sounds like an enormous increase in the amount of effort required. Compared with what we already have to do anyway, it's not as big as it might sound. So in summary, the science is clear. The risks posed for Australia and the rest of the world are clear, and that it would be irresponsible not to take those into account and try to reduce them. Australia would benefit from strong global action, and we do need to play our part. We do need to strengthen our efforts now. Otherwise we leave future generations with an improbably large task. We should be increasing our 2020 target. We should be thinking about stronger targets for 2030. And we should be doing. We should be looking towards all of the sorts of policies that we can and should be putting in place to reduce our domestic emissions for now. Thank you very much.
Thank you very much, Anthea. That's a great start to this colloquium. The intention with this colloquium in particular is to bring life to the public debate on the question of Australia's fair contribution, of course, and to generate some debate about this report in particular. So Anthea's given us a great start. We're going to move straight on to the next speaker, and I'd ask you to hold your questions till later. So please keep track of any questions that you wish to ask, and you'll have your opportunity to do that once we've heard from all four of our speakers. The next speaker is Professor Michael Raupach. Now, I've already introduced Mike at the beginning of the session, so I'm not going to go through that introduction again. Mike is going to talk to us about the implications of the global carbon quota, and in his experience with the Global Carbon Project in particular, I know that he's very well placed to do this. So, Mike, if you'd like to...
Thank you very much. The three talks that follow Anthea's in this colloquium are intended to move through aspects of this subject which in some sense back up what Anthea has said. And the first of these, this one, will concern the science behind this question of a carbon quota. The next will concern the issues of what pathways we can take. And the final talk by Frank will concern the question of affordability. We know that this question of setting targets revolves around a concept which has sometimes been called the global carbon quota. This screen has just turned itself off. That's interesting. That's because I pressed the button. Okay, here we go. Pardon me, my talk has somehow lost its place. There we go. We're back on track. The question of a global carbon quota depends on a series of scientific pieces of evidence, which I think it's very important in a forum like this that we not take for granted. We should not assume that the biophysical science is somebody else's problem and simply take those answers. We should at least acquaint ourselves with the basic moves that go into setting the carbon quota, and that's the intention of this talk. So I'll look at three things: the foundation of this idea, its implications both in terms of the timing and mitigation, and also the question of uncertainty and risk that Anthea alluded to, and finally, very quickly, a look at the question of how we might share the carbon quota. A way of framing this that is very common is to draw a trajectory for emissions. This particular one shows the historic emissions in black for carbon, for CO2, the most important of the greenhouse gases, together with four scenarios that were used by the fifth assessment report, recently published to look at future evolution of emissions. And the line that we want to follow is basically shown by the blue scenario, and the two dots represent where the world might like to be to follow that line in 2030 and 2050, calling for reductions globally of around 5 to 10% by 2030, below 2000 levels, and around 50 to 60% by 2050 for CO2 emissions. For Australia, the requirements, given that we are a developed country, as Anthea said, are substantially higher. From the global point of view, how are we going? Not so well is the answer. This is a zoom in of exactly that same picture, showing how emissions have tracked, global emissions of CO2 have tracked over the last 25 odd years, and the picture is that we are following very closely the highest, not the lowest, of those emission scenarios. So we have some work to do at global scale and, of course, at Australian scale. One way of defining that challenge has been through this relationship between climate change, quantified here by global warming, and cumulative emissions of greenhouse gases, and the most important of those is carbon dioxide, and so it's conventional, for reasons we'll come to look at the relationship between warming and cumulative emissions of carbon dioxide. And that way of looking at things was triggered by two influential papers in Nature published in 2009. There's been a good deal of work on that line of work since. The starting point for this is that emissions over the last century and a half have been growing close to exponentially. These two graphs show in the top picture CO2 emissions, the total in brown, the contribution from fossil fuels in red, and from land use change in green, plotted on a logarithmic scale on the vertical axis, so that if growth is exponential, we would see a straight line. And pretty much we do see a straight line. It's the dashed grey line with a slope of about 1.9% per year. And of course, the integral of an exponential is another exponential, and that means that if emissions are growing exponentially, so are cumulative emissions. That's what's plotted in the bottom picture, and we see that cumulative emissions, the quantity that we're going to try to manage, up to now, have also grown very close to exponentially with exactly that same slope. Why does this work? We can look back at past trends. Here's the temperature history of the planet from three different sources of data, and the average shown in black, plotted, pardon me, since 1850, plotted in the usual way against time. We can, prompted by this notion that there's a relationship between warming and cumulative emissions, we can change the clock. We can plot those data not now against time, but against the cumulative emissions that we saw in the previous picture, and we see, instead of the near exponential increase in temperature anomaly, a near linear change in temperature with a slope from the observations, not from models, which turns out to be about just under 2 degrees per 1,000 billion tonnes of carbon, written up there in a funny unit called exograms of carbon. Same thing, billion tonnes of carbon emitted as CO2. We can have a look at how this is going to behave in the future by turning to models. This is a simple model, but the results are very similar to the suite of very sophisticated models run in both the 4th and 5th assessment reports of the IPCC. The top picture shows a set of emissions trajectories, the black, the observations up to now, the 4 colours, a set of trajectories running into the future, corresponding in rough terms with the 4 trajectories that the IPCC has used, smoothed out a bit here for reasons of simplicity. The middle curve shows what happens to carbon dioxide concentrations in the atmosphere when the atmosphere is hit with this set of emissions. The bottom curve shows what happens to temperature. Just interestingly, the dark blue curve, this one here, is one that has become common to study in climate science. It's the Stop Emissions Now trajectory. It shows what happens if emissions were cut to zero immediately today. Clearly it's not a realistic trajectory, but it's an important one to study from the point of view of our understanding of the climate system. One of the things that it shows, if you look at the temperature response down here, is that if we stopped emissions right now, there would be a warming of about 0.5 degree before the cooling, a subsequent cooling. That warming is because by stopping emissions now, we turn off the aerosol forcing, which is negative at the moment. At the moment, aerosols, largely from fossil fuels, have a series of effects that add to a net cooling of the planet. So by stopping emissions now, we turn off that net cooling very quickly. There's a very rapid response of warming of about 0.5 degree. Now we change the clock again, exactly as we did with the observations, and we see that looking at the bottom right-hand picture down here, that, as we saw with the observations, the relationship between temperature and cumulative emissions becomes close to a straight line. That's what gives us confidence, that straight line, that this carbon quota idea has some biophysical reality and is a sound way of us, the world, constructing a set of policies as Anthea outlined. Turning to probabilities, it's important to recognise that there's uncertainty through this everywhere, and this picture summarises in cartoon form, but quite close to the results of the detailed models, the way this uncertainty looks. The dots are various projections into the future obtained from both the fourth and the fifth assessment reports. The black ones are the most detailed models from the fifth assessment report for the 4 scenarios that we showed before. The colours are a different set of scenarios from the fifth assessment report. The black line is a simple slope, linear, which assumes that for every 2 degrees of warming, there is 1,000 billion tonnes of carbon emitted into the atmosphere in the form of CO2. That turns out to be a quite robust result. The grey bars around that show the current uncertainty as estimated from a large number of sources, but they converge to a picture something like this. That black line, the 2 degrees per 1,000 billion tonnes, is the line that we would get if we said, let's have a 50-50 chance, a 1 in 2 chance of staying below the 2 degree target. If we want a better chance, let's say a 67% or a 75% chance, then our quota has to be proportionately lower. And the next picture shows what happens if we change that framing to a different plot. It's essentially the same information here, but what's been plotted, instead of plotting the cumulative quota on the horizontal axis, we've plotted the probability of success in meeting our target. On the vertical axis is now plotted the target itself, and the 3 colours, the quota, the emissions quota that we're going to adopt itself, and the 3 colours represent 3 different warming targets that we might adopt for the world. The blue, 2 degrees, the green, 2.5, and the red, a 3 degree target. So the 50% chance of meeting our 2 degree target is shown by this line. It translates to a quota here of 1,000 of our units, bearing in mind that we've already emitted 576 of those units. That leaves us with about 424 to go. If, on the other hand, we want a better chance, the one that Anthea alluded to, of a likely chance in IPCC terminology, which means a 2 in 3, 67% chance of meeting our target, things get a lot tougher at global scale, largely because the quota itself goes down a bit from 1,000 to 830 or so, but bearing in mind that we've already emitted 576 of what's now 830, the amount that we've still got to emit diminishes enormously to about 254. And we can, from this kind of calculation, derive a fairly simple rule, which once again turns out to be quite robust. Every time we ask for a 10% increase in the confidence with which we're going to meet our target, say 2 degrees, we have to lower our target by 100 of our units. So the target, if we want a 50% chance, it's 1,000. If we want a 60, 900, and so on. Finally, the question of how we share this cumulative emissions quota. I'd like to touch on the idea of contract and converge that Anthea alluded to, but briefly in a rather simpler way than it's often presented, and that's to look simply at the question of how we share this cumulative emission pie. For the moment, let's not worry too much about the size of that pie. Let's just assume that there is one, that we've defined a quota, and let us say, for argument's sake, that we look at how that quota would be shared if we continue our emissions trajectories essentially as we have done in the past. That means that countries continue to emit the fractions of the world's emissions that they are roughly now. And we get a sharing something like the pie shown on the left thank you. Now let's suppose that rather than sharing by current or past emissions, we share by population. We take account of the fact that many of the developed countries of the world, including us, have far higher emissions per unit per capita, per person, than developing countries, and that it's important that equity considerations factor this into account. This would give us a very different sharing. And we can also imagine a compromise sharing where we would share by some mix of population and historic emissions, looking something like the picture in the middle, and we can write down a little formula for how that sharing works. Now, let's look at the consequences of this for how fast we have to reduce our emissions to meet the targets that these three proposed rules would now impose. And they've been plotted here in the following way, that on the horizontal axis of this picture, where the colours represent a set of different countries, is plotted the present per capita emissions per person. On the vertical axis is plotted a mitigation rate, which is the rate in percent per year that we need to reduce our emissions in order to meet the quota. Anthea alluded to an emissions reduction of about, I think the number was 17 years that it gave us. So that would be a reduction rate of a little over 5% per year if that was applied in a linear way. So this picture, by looking at the emissions reduction rate that we are called for, illustrates the different ways in which these rules impinge on the challenge that different countries are facing. Let's start with the world here. For the world as a whole, it doesn't matter how we share the quota because everybody's in it together. Move now to developed countries such as Australia or the US on the right of the diagram, where there are large per capita emissions. Here, there are very significant increases in our commitment measured by this mitigation rate as we move from an inertia set of rules through the compromise rules to the equity rules, basically moving up this picture. Similar picture for the US. Look now at the other side of the diagram where, for instance, for Ethiopia or for India, take Ethiopia, the one right on the left, what happens is that as the world moves from inertia as a sharing rule through to full equity as a sharing rule, the challenge for Ethiopia diminishes because Ethiopia is being helped by that sharing rule. Essentially, emissions challenge is being taken from developed countries and given as a means of development to developing countries. And the result of this is that the world pivots around the point represented in black there, so that the challenge, and as the rich contribute through moving towards equity, the poorer nations, the developing nations, gain benefits. The result is that we can measure, as a result of how much the rich give to the poor, how much benefit they obtain. The answer turns out to be that a little equity, a little movement by the rich goes a very long way in helping the mitigation challenge for the developing countries. And the reason essentially is that because the rich have very large emissions per capita at the moment, relatively small reductions in those emissions can achieve a great deal in terms of equity. One of the other points of this diagram is to look at what's realistic in terms of technological reductions at the rates at which we can reduce emissions. It's likely that a rate of somewhere in the order of 5 to 10% is the maximum the world could do. because if we were going to achieve more than that, we'd essentially need to be turning over the plant by the capital, the equipment by which our energy and transport and so forth are maintained at rates which approach 10 or fewer years, and this becomes technically unrealistic. So this diagram includes a band somewhere between 5 and 10 on the vertical axis, which is the limit of feasibility. And that's the importance of looking at rules which are not just the equity rule, but include compromise. So finally, the summary. To stay below 2 degrees, we have an allowed emissions quota. It's soundly physically based. 1,000 petagrams, 1,000 gigatons of carbon gives us about a 50-50 chance of success, about 830 for a 67%. However, we've burnt about 570 and slightly more than that of that quota. So the remaining quotas increase their challenge dramatically as we reduce the quota. The factors affecting that quota, obviously the warming target, the chance of success, whether it's 1/3, 2/3, 1/2 to 2/3, and each 10% of increase in that chance of success lowers the quota, makes things tougher by about 100 of our units. Whether or not we include non-CO2 gases is important. I haven't been able to go through that in the short time available, but non-CO2 gases are factored in here. We're looking at carbon, but the consequence of us nailing our carbon trajectory is that there'll be accompanying changes in the non-CO2 gas emissions which cause these results to a quite good approximation to follow through. And in sharing the quota, a little equity goes a long way, and it translates the challenge from unachievable to something that is within our bounds if we really work at it. Thanks very much.
Thank you, Mike. We now move on to a presentation which is going to look at deep decarbonisation pathways, which follows very well, I think, from the challenge that Mike has outlined for us with his presentation. We're going to hear about these deep decarbonisation pathways from Scott Ferraro, who is Head of Engagement at ClimateWorks. ClimateWorks is a partnership with Monash University in Melbourne, and Scott has been there since January of last year, following a period as Executive Officer of the Gippsland Climate Change Network. Scott has a background in environmental engineering and has sat on the working group for the Low Carbon Growth Plan for Gippsland and undertook subsequent work to coordinate the implementation of the opportunities identified in that plan. And I guess no more is really needed, Scott. So we're going to hear from Scott about deep decarbonisation pathways.
Thank you, and good morning or good afternoon still. I think it was meant to be good morning when I arrived, but Qantas assured me that for my safety I should be 2 hours later than planned. So I'm happy to be safely here with you today. And thanks to Mike and to ANU for the invitation to present today. I'm talking around a project that we're actually working in partnership with ANU on. So Frank Jotzo is the ANU lead on this project, and it's looking at deep decarbonisation pathways out to 2050. So I'll go through this project in a little bit more detail for you. So just quickly for you, ClimateWorks is a not-for-profit partnership between Monash University and the Maya Foundation. So we're philanthropically funded through the Maya Foundation. And we've basically got a mission. We've been set up to help catalyse greenhouse gas emission reductions across the Australian economy. So you might be familiar with some of the work we did with our low carbon growth plan for Australia, which looked at emission reduction opportunities out to 2020, trying to achieve a 25% emission reduction across Australia. And then also recently we completed a tracking progress report looking at what's actually been achieved and what's likely to be achieved by 2020 as well. And that report showed that based on current trends and current activity, with the current policies still in place, we'd be looking to achieve around about 40% of the 5% emissions reduction target by 2020. So there's still lots more work to be done. So this project is focusing on 2050. So really looking out into the future and what's required to achieve deep decarbonisation. It's been led by the United Nations Sustainable Development Solutions Network, and they're coordinating 13 countries to undertake this modelling. ClimateWorks and ANU are leading the Australian efforts on this project as well. So you can see the countries involved and regions as well, because the EU is involved. They cover off around about 75% of global emissions. So the project's really focused on a bottom-up modelling effort, looking at what can be achieved rather than the burden sharing type approach as well. So really looking at what's needed to achieve the 2-degree target by 2050 to feed into some of the global negotiations that will be upcoming in the near future. So hopefully you're familiar with this graph from this morning's presentation, but really what this shows is that depending on what we do over the next 5 years or so, the early action that we take is going to determine how steeply we have to achieve emission reductions into the future if we want to achieve that 2-degree target. So this project's working on the CCA's carbon budget analysis that's been done and working in with that. So as I mentioned before, the project itself, we're looking to have a report published in July for this project, looking at a first modelling run and some initial analysis. And that ties into the September 2014 UN Secretary General, who's convening the heads of state for a climate change summit. And then in June 2015, there's going to be a second phase of this project, which does some more robust analysis and also starts to engage locally with industry and government around what's required across Australia. And again, that's focused to feed into the December 2015 COP21 in Paris. So this is being driven again by the UN SDSN, but we're looking at it locally around what's required in Australia and what can we actually do. So the modelling that's been undertaken by this project is we're working with CSIRO, and they've got a number of models which we're utilising. So we're really, due to the tight timelines from the UN, working off existing work that's already been done and feeding that into their models. So we're using their power model, transport model and land use change model. And then based on some work that ClimateWorks has done around buildings and industry analysis, and then also some broader modelling parameters which are being set from IEA's work. And so then this work is then being fed into what used to be Monash University's Centre of Policy Studies MMRF model. They're now at Victoria University. So we're looking at the broader economic modelling and the economic implications of this modelling. So really, from a deep decarbonisation perspective, from the global level, we're assuming that it's going to drive significant change if we are to stick to the requirements to minimise warming to 2 degrees. There will be both positive and negative implications across the global economy. We're taking this analysis from the assumption that for Australia, we've actually had a long history of adapting to and benefiting from these broader trends in the global economy. Some examples we've got listed there have been we traditionally prospered from gold mining and wool production, which then changed into sort of coal mining and minerals extraction and those sorts of things. So we think Australia is well placed to deal with these broader international trends, and that we can actually take advantage of this deep decarbonisation opportunity due primarily to an abundance of low carbon energy sources and other natural assets, which could give us a comparative advantage, which I'll touch on shortly. So the project really has a focus on what can the Australian economy look like in a decarbonised world. So we're looking at decarbonisation with economic prosperity. Some of the work that we're going to be doing is looking around what are some of the opportunities for Australia in this context, what sectors are going to face large uncertainties, and how can we actually manage these. And then also what are some of the implications for Australia's economic structure. So this first phase of the project we're really using to then inform those discussions in the second phase as well. So we're looking at how decarbonisation can be achieved. So the UN sort of set the objective of what are the technical opportunities that you can take advantage of to achieve decarbonisation, and the modelling from the bottom up. So those 13 countries are looking at how hard can they push their economy, and what can realistically be achieved, and then what are the challenges that come out of that and some of the global trends. So some of our colleagues are in Paris at the moment for a secretariat meeting where they're getting some initial views of the modelling results from the other countries, which will be really interesting to then feed back into our own modelling efforts. So deep decarbonisation, we're looking at 3 major pillars which can drive this activity. And some of these have been driven by the UN, but then also within Australia, we've got our own national context which we've considered. So we're looking at optimising energy productivity, a shift to low carbon energy sources, and then other abatement and sequestration opportunities. So for this project, we're modelling in phase 1, one potential pathway, but we're acknowledging that there are many potential pathways that could be taken. And so we're doing qualitative assessment around what are some of the uncertainties and what are some of the trade-offs between those different pathways and technologies. So if we look at the first pillar around optimising energy productivity, what we can see is that there's 3 main factors which influence this pathway. So we're looking at substantial improvements in energy efficiency, which could be across industry, buildings, passenger transport or freight transport. Changes in lifestyle and consumer preferences, so this could be such things as home design, urban design, response to changes in the environment, and travel distance as well. And then more broadly, structural changes in the environment. So this is changes in global demand, product substitution, changes in relative competitiveness, and also changes in how societal needs are met. So I'll show you the preliminary pathway that we're looking at from this perspective. And so the colours indicate how hard we've pushed these levers, again acknowledging that there's multiple pathways for each one of these levers that we're looking at. So for the pathway that we've considered, and again we've built off existing modelling and assumptions that have been completed, and also some heavy academic and industry engagement that we've undertaken over the last few months to sense check these assumptions. So we're really looking at substantial improvements in energy efficiency without significant changes to how people live or how the economy is structured. So from energy efficiency, we're looking at sort of medium improvements in both industry and freight transport efficiency, but then also highly significant savings, energy efficiency in buildings, and then also in passenger transport as well. The second pillar, which is one of the most significant ones, is looking at a shift to low carbon energy sources. So again, from this perspective, we're looking at decarbonisation of electricity, and there's a number of ways to achieve this, either through centralised renewables, nuclear, distributed renewables or CCS. Decarbonisation of direct fuel use, which is mainly within industry, so either through bioenergy applications or CCS as well. And then electrification of other energy uses. So this could be electrification in industry, within transport as well, and within buildings and transport modal shift as well. So shifting from road freight to trains and those sorts of things. So in the pathway that we're currently modelling under here, this is where we're looking to achieve significant savings. So we're looking at adopting best technology available in decarbonisation of electricity. So I'll touch on this one in a little bit more detail because we're running a few sensitivities around this. So for the central scenario that we're looking at centralised renewables, sun distributed renewables and CCS. decarbonisation of direct fuel use. We're looking at adoption of bioenergy by industry. And then electrification. So we're looking at significant electrification of buildings, but then also within industry, and then within transport vehicles, and then also a significant shift, transport modal shift. So as I mentioned, in the power sector, we're running some different scenarios because there's existing information on these scenarios which has been run out there already, and it's also one of the major decarbonisation opportunities, so we want to test our assumptions on this one. So we're looking at a scenario which includes nuclear as well. So that includes renewables, both centralised and distributed, and then nuclear. That's in place of CCS. We're looking at a 100% renewables scenario as well, which has got centralised and distributed renewables. And we're looking at potentially running a highly distributed scenario, and that's to test the impacts on the grid as well, if we've got time to run that one, depending on how everything goes in Paris. So the third pillar is looking at other abatement opportunities, which are mainly non-energy related, and sequestration opportunities as well. So carbon forestry is an opportunity, so looking at both reduced deforestation, marginal land reforestation, productive cropland reforestation, and pasture reforestation. Reduction of industrial non-energy emissions, so using catalysts in some processes. CCS could also play a part here as well. Product substitution and shift to less emission intensive fields or mines. Then the third part of this is looking at a reduction of soil and livestock emissions. So this is building on soil practices, potential beef demand reduction, cattle diet management, and changes in cattle density as well. So the pathway that we've modelled here is looking at, I guess, a step change in carbon forestry. And this is based on achieving the decarbonisation by 2050. So we're looking at marginal land reforestation, productive cropland reforestation, pasture reforestation as well. And this is based on some of the CSIRO's latest modelling. We're looking at best technology available with regards to industrial non-energy emissions, so looking at CCS within industry, and then also a shift away from some of the more intensive fields and mines as well, and then some advancement in the use of catalysts in some chemical production. And then with reduction of soil and livestock emissions, looking in changes in cattle density and cattle diet management, rather significant changes. Only a medium change in beef demand reduction, and this has been driven by global trends as well. So we're looking for input on the UN on that front and some soil practice changes. 3 minutes, perfect. So that's all I can show you for the results for now because they're in draft, unfortunately. But really what we're seeing is that we can achieve decarbonisation with strong GDP growth and also growth in exports as well. So keep your eyes out for the report when we release it with some more detail on that. There is a significant amount of uncertainty when doing this modelling out to 2050, so we're factoring that in to how we go about doing our qualitative analysis and diving into this and some of the trade-offs as well. And I've listed a few of them there, but we have a document which has got a significant amount of uncertainty, so we're factoring those into our modelling. There's also a significant number of challenges that we're identifying as we go based on our consultation as well, which we're going to dig into a little bit deeper. One of the main ones that keeps on coming up is the political and regulatory certainty that's required to achieve these long-term changes and shifts as well. But we believe these can be overcome by some early planning and some more rigorous consultation. Just to finish on, I guess the 2050 isn't that far away. If you have a think about it, I guess first year students here at ANU in 2050 will be the same age as the current Prime Minister in 2050, and 11-year-olds, so grade 5, grade 6 students will be the same age as Joe Hockey and Greg Hunt as well. Infrastructure that we build today and over the next few years will also be around in 2050, so we need to start considering these things. A lot can also happen in the 36 years we've got as well. I'll just point to the mobile phones at the bottom there compared to the old style telephones that we used to have. So it's technological advances are required. We've been working a little bit with Toyota, and they gave us some insights into, I guess, vehicle development, and really they mentioned ABS as one of the issues. So ABS was first around in a 1966 vehicle, but it really didn't become standard in the Australian markets till 1990. So these things do take time, especially when you're looking at vehicles. You're talking about 4 full model runs before something becomes mainstream and diffuse as well. So we need long lead-in times to get these things up and running. I think that's my time, and that's it. Thank you.
Thank you very much, Scott, and obviously that's left us all in suspense, waiting to see what's going to be in your report. The approach looks very interesting, and the results will no doubt be fascinating. Lots of food for thought there. Our next presentation, and the last of the 4 presentations before we'll move to Q&A and discussion, is going to be given by Frank Jotzo. The title of Frank's presentation is a 15% reduction by 2020 affordable? Well, that's what I've got here. Here it says it's a stronger emissions target for Australia, costs and prospects. Frank is well known to many of you, I'm sure. He is Associate Professor at the Crawford School, and he is Director of the Centre for Climate Economics and Policy in the Crawford School and here at the ANU. He works on the economics and policy of climate change, energy, and on broader issues of economics, environment and development. He was an advisor on the Ghana Climate Change Review, has also advised Indonesia's Ministry of Finance and the World Bank, including the Partnership for Market Readiness program, and is a lead author of the 5th Assessment Report of the Intergovernmental Panel on Climate Change. So Frank, we look forward to what you have to tell us. Thanks.
Thanks very much, Jeanette. Thanks very much, Mike. Mike, you asked me to talk about the question of whether 15% target is affordable, and I think the answer is so obviously, well, yes, of course, if it's done right, that I decided to frame the topic a little bit more broadly than that. It's a good question, but it's so easily answered. So 15% target for 2020. There's been a few analyses that have looked at the question to what extent that is justified in terms of Australia's interests, in terms of other countries' pledges and actions. I dare say none of these analyses have been quite as detailed as what we've had in the targets and trajectories or targets and caps report from the Climate Change Authority. So wonderful work, and I think an excellent resource for years to come as well. Modified contraction and convergence was mentioned before. The framework applied in the Ghana Climate Change Review and also referred to in the Climate Change Authority's report. Now, in terms of the near-term trajectories that you can work out for different countries and what contraction and convergence to equal per capita emissions might mean, there's many ways of slicing and dicing this, and you can calibrate a modified contraction and convergence framework in many different ways and arrive at different answers as to what a 2020 very near-term, equitable, fair emissions target might mean. But really the inescapable fact is that over the medium to longer term, we would need to see drastically reduced net per capita emissions in Australia if the world is on a path of strong mitigation and if Australia were to play a proportionate role in that. Okay, so that's really simple. And then the question is just how fast do you start and how does that all fit together with other countries' actions. And in that regard, I think, just like you said, Anthea, I completely agree, you really only need to look at the US and China, and you get a very strong indication out of that what that might mean for Australia. The US are more or less on track towards their 17% reduction target. There's a 20% reduction target in place in the EU with much stronger reductions foreshadowed for 2030. And we're seeing significant action on climate change mitigation to rein in emissions growth and to substantially reduce the emissions intensity in the Chinese economy. And out of that, it's fairly easy to deduce that some extent of significant cut in net emissions for Australia is what the world will expect of us if we want to be seen as playing a role. I think it's important to keep in mind that point that Professor Garneau put so strongly on the map in this regard, and this is Australia's national interest in strong global action on mitigation. We're likely to be among the most vulnerable countries to climate change among the developed world, and so intrinsically we will also have among the strongest interests in the world actually acting on that issue. That, of course, clashes with more sectorally concentrated and nearer-term interests that may go the other way in terms of desires to maintain a strong position in fossil fuel markets and maximize the amount of revenue that can be produced from Australia's fossil fuel assets. On emission reductions, it's kind of worth looking at some of the material that has come out of the IPCC Fifth Assessment Report this year from Chapter 6 in the Working Group 3 report released a fortnight ago. So what you see here is the ranges for emissions reductions at 2030, so 2030, not 2020, for broad country groups under different approaches to burden sharing or effort sharing. And the headline here is that the OECD countries under different schemes of what might be considered fair would be expected to reduce emissions by between 30 and 60% at 2030 compared to 2010. Okay? Now, among the OECD countries, of course, you would expect a fair bit of differentiation as well. And among the OECD countries, we are the one with the highest per capita emissions. And so that in itself would point you towards Australia being at the more ambitious end of the 30 to 60% range that is postulated here by the IPCC. Costs of a stronger 2020 target. Well, the move from 5 to 15%, and I'm using the Climate Change Authority's number here, may result in an additional reduction in net emissions of about a total of 300 million tonnes until the end of this decade. Okay, so roughly speaking, something below 50 million tonnes per year. Okay, the move from 5 to 15. It's really pretty simple. Net total emissions are somewhere in the 550 thereabouts million tonnes. You're taking 10% of that and you average it out over, you sort of ramp it up over time. Now, if you do that extra 10% through purchases of external emission credits, I checked last night, the price in the markets for a certified emission reduction credit from the Clean Development Mechanism is in fact 14 euro cents. So, you know, I mean, I think with the dollar per ton, you're kind of quite generous there at the moment. And in fact, you know, I mean, if you could buy these privately, this would be the time to offset your lifetime emissions, right? You'll easily be able to do it on your credit card limit, perhaps for your whole family, in fact. Now, if you do this using EU allowances at today's price of about $8 per tonne, the bill would come to around about $400 million per year. okay, for a move to a 15% target from a 5% target. So that's a quarter of 1/1000th of Australia's GDP. Okay, so it's a non-negligible sum of money, but it's still it doesn't register in terms of overall macroeconomic impact. It gets completely lost among week-to-week exchange rate movements, for example. The alternative route would be to use domestic abatement to achieve a stronger target. Of course, this would then happen at higher marginal cost and possibly higher total economic cost, possibly. It just depends how this is implemented and what the dynamic effects of domestic mitigation policy actually are. Reality tends to be a little bit more complex than the economic models we apply to these things. And of course, it would have an actual impact on Australia's emissions trajectory and thereby serve to help prepare for the longer-term transformation should that occur. I'll show you some other numbers here. The point here being that if we look at modeling analysis over time, the estimates of what a stronger target might cost have actually come down significantly. Here we're comparing scenarios for 25% emission reductions from the Treasury modeling and the Garno review scenarios in 2008 and 2011, respectively. You see this, I mean, they're different scenarios, but at the base of it is something similar. Costs come down from 2008 to 2011, and when this was redone in 2013 by Vivid Economics for WWF, the report is available publicly, and using essentially the same modeling tool, well, using the very same modeling tools and using very similar setup for the modeling, we saw the estimated cost of a 25% target come down significantly from earlier estimates. Why is that? Two reasons. Well, one, abatement cost, the cost of abatement has come down, in particular through cost savings or lower costs and lower future cost estimates for renewable energies. Secondly, Australia's underlying BAU emissions growth trajectory is lower now than it used to be then. Okay? And thirdly, and in the context of an analysis like that, most importantly, the estimates of future international carbon prices have come down drastically. And so any scenario that relies significantly on external purchases of emission offsets, of emission units from Europe or elsewhere, shows you much lower cost than estimated previously. Low costs of strong mitigation, also a headline message from the IPCC. So on the basis of a very large run of very many different economic models, the headline message is that mitigation costs, even under relatively strong scenarios, can be less than 0.1% of GDP impact per year. Okay, 0.06% is the headline number there. And of course, this effect is cumulative, so this is why we're getting that range of between 3 to 6% or thereabout at 2050. That translates into less than 0.1% of GDP per year. Okay, so going from 3% GDP growth globally per year to 2.9% thereabouts. Okay. Now this is of course under an idealized implementation scenario. So this is all countries acting, all sectors that can provide cost-effective mitigation being part of the mix and using cost-effective policy mechanisms. So the standard assumption in these models is a carbon price across the economy, across all economies, possibly supplemented by non-pricing mechanisms where these are economically efficient. Okay? This is not modeling a sort of more selective approach that we will likely see emerging in Australia. Now, why would we take on a stronger target? I'm trying to kind of take a sort of a simple approach to splitting out some of the possible reasons. First of all, maybe Australia wants to be a good global citizen. Okay, so a more defensive approach. Let's neutralize to some extent possible criticism of Australia in terms of our international role. Secondly, influencing others. Okay, so it's been quite well established, and on the international stage, we probably have greater visibility and potentially can wield greater influence than our 1.5% of the global economy and global emissions might suggest. Okay? And thirdly, of course, preparing for low carbon transformation domestically. And how do different ways of achieving a stronger target, say a shift from a 5 to 15% target, potentially match up against those possible policy objectives? Buying CDM credits would certainly put a tick in the box of being a good citizen, because we'd have a stronger target, one more in line with what other countries might expect of us, and we'd be fulfilling that, as you've pointed out, Anthea, through acknowledged and legally viable international units. Will we be influencing other countries to do more? Well, I don't know. I think it's very much a question of how this will be perceived. Will it be perceived as a cop-out in terms of complying with a stronger target at the cost of a few tens of millions of dollars per year? Or will it be perceived as a positive contribution to maintaining the integrity of an international system of pledges, targets, and emission reductions by providing at least some amount of money towards the accumulated surplus of CDM credits, and thereby to some extent helping with the credibility of possible future mechanisms that involve developing countries. Nothing on domestic transformation, of course, negligible macroeconomic cost. Buying EU emissions trading allowances probably puts more of a tick in the box of actually influencing others, right? Because this would be part and parcel of the previously planned link to the EU emissions trading scheme, and would thereby give Australia a stronger position of influence in EU and possibly other schemes that might be linked up in the future. More mitigation at home, of course, would give bigger ticks in all of those boxes, but also at likely larger costs. Still not a very large cost at all, if done cost effectively. Finally, perhaps one to flag that traditionally has always been an attractive way to go to governments of whichever persuasion, and that is to thoroughly probe the accounting rules and mechanisms, in particular in the land use sector in Australia, and see what can be squeezed out in terms of actually coming up with a more favourable number without actually changing anything on the ground. So we've seen a lot in that space over previous years under both governments, and I would hazard a guess that we'll see more efforts in that direction in the future. 2020 is somewhat of a distraction, actually, and I hope that the effort that ClimateWorks is leading there and at the global level as well will help us to reframe the discussion in this country a bit away from this kind of politicized debate over how we're going to achieve the 2020 target or whether we'll achieve it or not. The meat is really in the 2020s and the 2030s. Will we stay on a business as usual track that will see Australia's absolute emissions keep increasing for a long time to come, or will we see a turnaround to sustained and significant decline? Again, it's been established quite clearly through economic analysis that the earlier we move, the easier it is to position for a low carbon world, the less the shock if and when we need to adjust to that. We asked the question about costs. It's really important to consider costs to whom. There isn't too much argument these days over the overall macroeconomic costs if things are done well. Most of the argument and the heat and the noise is really over who these costs accrue to. So we see impacts concentrated, just like Scott said in the presentation. Actually, overall economic structure doesn't change so much, but of course particular economic activities, particular impact industries see enormous impacts, and that's really where we're seeing the lobbying, that's where we're seeing the political resistance to significant change in those areas come from. So it's fear of change, and really, at the end of the day, will we see action or not? Again, you can try and put it into a sort of a system of categories here. If you believe that the world will not act, right, then it's quite easy to come to a position where you say Australia should also not act. There's no change, no action, okay? If you believe the world will not act, and you say that Australia should act, then perhaps you're taking a sort of an ethical perspective with a good dose of hope that action by Australia could, in fact, spark the global community to do more. But many would dismiss that kind of course of action as largely a gesture. If you believe that the world will act, okay, then you could still take the position that Australia should not act and resist change, and I think that's what we're seeing quite strongly, and we see that kind of position really very much in resurgence. Or you come to a position, a top left quadrant there, that you believe Australia should act and being part of the change. Now where we're at, and I'll just take one more minute, is I think we're very much kind of slipping into that lower quadrant, lower part of the box, okay? Either on the left or the right, yeah? Australia should not act, either combined with an expectation that the world will not be doing much, or coming at it from a normative perspective where, well, maybe the world will be acting, but in Australia we shouldn't be doing anything. So this, of course, has come out of this sort of really unfortunate political development in this space, where climate change policy has really become a sort of a headline issue of adversarial politics. And I think, when you think about what this kind of community will need to do over the next few years, possibly over the next decade, is to try and take the politics out of this issue, okay? And keep reminding the nation about the costs of inaction. Okay? So when we're talking about the costs of action, we ought to balance that with the discussion of the costs of inaction, both in terms of climate change impacts and in terms of positioning of Australia's economy and positioning Australia diplomatically as well. So I guess we're expecting that this will be the last major report by the Climate Change Authority on that particular issue for some time to come. But equally, I'm actually quite optimistic that this report will have a long shelf life. Right? Not only because there may not be too many similar publications for some time to come that will supersede it on the shelf, but also because it's actually a tremendous resource, and I really recommend reading it. So thanks very much.